Hi guys, so let's continue after we have 3.1 Introduction to Hypothesis Testing and all the procedures. So now we have 2.2 Hypothesis Testing for a population mean. So we will use the 5 steps in hypothesis testing for a population mean. So in hypothesis testing for a population mean, we want to test a population mean when the population variance is known or unknown. So step number 1, so you have to formulate the hypothesis. Okay, so it's either two tail, right tail or left tail. So it depends on your question. And then the test statistic used to test the hypothesis testing for 1 mu, we have to consider the cases. If population variance is known, we have the first formula. Okay, x bar minus mu naught over sigma over square root n. X bar is the sample mean, mu naught is the value of your parameter, and the sigma is the population standard deviation, n is the sample size. Okay, when the sigma square is not given, is unknown, you have to consider the sample size. If the sample size greater than or equals to 30, use the second formula, where the difference between these two is here is s, because sigma is not given. Okay, when the sample size is less than 30, you have to use a t-test. Okay, so what is the difference between the two? This one is z-test for greater than 30. This one was t-test because of less than 30. Okay, let's look at example. Hypothesis testing for a population mean. Okay, let's try to look at example 3.2. How to conduct hypothesis testing for one population mean, 1 mu. Okay, read the question. Most water treatment facilities monitor the quality of their drinking water on an hourly basis. One variable monitored is pH, which measures the degree of alkalinity or acidity in the water. A pH below 7 is acid, above 7 is alkaline, and 7 is neutral. A water treatment plant has targeted a pH of 8.5. So the water treatment plant to target the pH 8.5. Okay, the mean and standard deviation of 1 hour's test result based on 31 water samples at the plant are 8.42 and 0.16 respectively. Does this sample provide sufficient evidence that the mean pH level in the water differs from 8.5? Use the 0.05 level of significance to test the hypothesis. So the question is hypothesis testing, because the question asks you to test the hypothesis. So it is a hypothesis. Okay, hypothesis for what? Hypothesis for the mean. So hypothesis for mu. Okay, so the first step is when you read the question, you extract the information. It said that the mean and standard deviation for 31 water samples. So your n is 31. From this 31 sample size, they give you the sample mean is 8.42 and the sample standard deviation is 0.16. So the question asks you, does this sample provide sufficient evidence that the mean pH level in the water differs from 8.5? So mean pH level targeted 8.5. So the mean pH level here is population mean differ from 8.5. So you have to test. So you have to test this statement. Mu differ from 8.5. So look at step number 1. Step 1. Okay, step 1 is formulate your hypothesis. Your hypothesis must have H null and H1. So H null on the left side here must be theta. Theta is parameter. So the parameter here now is mu. So you put here mu, you put here mu. Okay, on the right side of the hypothesis will be the values. What is the value from this mu? 8.5. So you put 8.5 here. Both is 8.5. So now at the middle here will be the symbol. Equal, greater than, less than, greater than equal, less than and equals, or unequal. So which symbol do we refer to? We refer to the keyword differ. Differ is different from 8.5. So it's not equals to 8.5. So that is if not equal, it is H1, because H null is always equal. So H1 not equal. which hypothesis that you put the symbol first, it will be your claim. Okay, and if H1 is unequal, H0 will be equal. So this is your hypothesis, step 1. Okay, for step number 2. Step number 2 is your test statistic. For step number 2, test statistic, we will refer our formula in the stat table. So which formula we want to use, z-test or t-test? Look at our formula here. Okay, look at our formula here, right? Okay, hypothesis testing for mu. Hypothesis testing for mu. So we have 1, 2, 3 formula. Z-test, Z-test and T-test. So which formula do you want to use? If you want to use formula number 1, sigma must be given. Look at our question. Is there any sigma given? No, there is no sigma given. So you cannot use formula number 1. Right, so if you want to use formula number 2, sigma square is unknown but sample size greater than 30. So look at here. So our sample size is 31. So now we can use formula number 2 because our n is greater than 30. N is equals to 31. So use the second formula, z-test. So the formula is the formula is z-test is equals to x bar minus mu naught over s over square root n. So now what you have to do is you have to substitute all the values. We have our x bar is 8.42. Our mu is here. This is mu naught. Okay, this is our mu naught. Mu naught is 8.5 over s. S is 0.16 over square root n is 31. Okay, now you calculate, put it into your calculator, you will get the z-test. So the z-test value here is negative 2.7839. So done for step number 2. Okay, step number 3. Right, step 3 is your critical region. In critical region, you have to determine your hypothesis, one tail or two tail. So we look at the hypothesis again. Okay, our hypothesis, the symbol is equals and unequal. If equal and unequal, it is a two tail. So remember that if it is a two tail, alpha must be divided by 2. So you will have a normal distribution. Two tail, it is a two shaded region, and you put the plus and minus sign. Here is minus, here is plus sign. So how many percent? Alpha is 0.05. So alpha over 2 is 0.025. So if here is z-test, here is z 0.025. So z 0.025 is equals to 1.9600. So you put the critical value here, negative 1.96 and positive 1.96. So done for step number 3. Step number 4 is your decision. The decision is about H null. You want to reject or you want to accept the H null. We base on the step number 3. Okay, look at our test statistic. Our test statistic is negative 2.7839 here. Where is it located? Negative 2.7839. Is it located in the shaded region or unshaded region? Shaded region is rejection region. So this is our rejection region. Alright. and the unshaded will be the acceptance region. So where is it negative 2.7839 is located? Negative 2.7839 is less than negative 1.96. So it is here. Is less than negative 0.96. Negative 2.7839 is here. So it is located at the shaded region. So it is located at the rejection region. So you have to reject H null. Since Z test is equal to negative 2.7839, it is less than negative Z 0.025 is negative 1.96. You have to reject H null. Okay, so last step is step number 5. We want to conclusion. So when you write down your conclusion, start with at alpha. How many alpha we use? We use here 0.05. So at alpha 0.05, okay, you enough evidence or not enough evidence to support your claim. So that's why the claim is very important. So look back our step 1. So look at back our step 1. Step 1, okay, at alpha 0.5. Step 4, we reject H null. So in step 1, you discard your H null because you reject this one. You accept this. Okay, so you accept this one. Means that you accept the claim. You reject H null and then you accept the claim. So at alpha 0.05, there is enough evidence to support claim that the population mean differ from 8.5. So means that our mu is not equals to 8.5. So it is different from 8.5. Alright. So that is the step how to conduct the hypothesis test. Think for one population mean. Alright, let's try to do exercise 3.2, number 1. Hypothesis testing for one population mean. Okay, read the question one by one. The lecturer state that the IQ score for IPT students should be higher than the other people's IQ, which is known to be normally distributed with 110 and standard deviation 10. To prove his hypothesis, 25 IPT students were chosen and they were given an IQ test. The result shows that the mean IQ score for 25 IPT students is 114. Based on previous study, it is known that the standard deviation of the IQ score for IPT student is 10. Can we accept his hypothesis at alpha 0.05? Okay, from the first sentence, there's the claim there. The lecturer state that. Okay, lecturer state that the IQ score, so the IQ score for IPT student should be higher than others. Say IQ score IPT higher than others, which is known to be normally distributed. So the score is follow normal with mu 110 and standard deviation 10. Okay. To prove his hypothesis, 25 IPT students were chosen. So N is equals to 25. They take a sample 25 and they were given an IQ test. The result shows that the mean IQ score for 25 students is 114. So among these 25 sample, the mean is X bar equals to 114. Okay, based on previous study. So previous study is population. So previous study is known that the standard deviation. So standard deviation population is sigma is equals to 10. Can we accept his hypothesis at alpha 0.05? Okay, now you want to test the hypothesis. So what is your H null and your H1? step 1 is H null and H1. So what is the parameter here? Parameter here, we talk about the mean. Okay, so it should be mu. Right? And the mu here is equals to, so if you remember, if follow normal, here is mu, here is sigma square. So our mu is equals to 110. So what we want to test? We want to test the lecturer state that IQ score higher than others. Higher than the symbol is this one. So H1 or H null, this symbol. H1. So greater than, and this will be your claim. See, the lecturer state that the IQ score must be greater than others by 110. So if H1 greater than, H null is less than, and put the equal sign. Okay, next, step number 2. Okay, step 2 is your test statistic. So which test statistic you want to use? So we look at our formula. Do we have sigma? So look at back the equation. Yes, we have the sigma. Sigma is given. So straight away use the first formula. Okay, use this formula. So substitute all into the formula. Z test is equals to x bar minus mu naught over sigma over square root n. So x bar is 114 minus mu naught 1110 divided by sigma is 10, n is 25. So substitute into your calculator, you will get the z test is equals to 2. Okay, next, step 3, the critical region. One tail or two tail? One tail or two tail? Look at here. H1 is greater than, so it is a one tail and right tail. So alpha is alone. Alpha 0.05. Then Z 0.05 is equals to 1.6449. Look at your stat table. Then when you draw the shape here, it is a right tail. Shaded region on the right, put the positive sign. So 1.6449 here. Okay, done. Then step 4. You want to reject or accept H null. Look at our test statistic. Test statistic is equals to 2. So where 2 is located? At the shaded region or unshaded region? Okay, 2 is located here. It is greater than 1.6449. So it is located at rejection region. So you have to reject H null. Okay, since Z test is equals to 2, is greater than Z 0.05 equals to 1.6449, and it is also located at the rejection region, you have to reject H null. Okay, so now decision is reject H null. So what will happen to the conclusion? Okay, look at our hypothesis back. We reject H null. So we reject H null. We discard this H null. So we accept this one. Do we accept the claim? Yes, we accept the claim. So at alpha 0.05, there is enough evidence to support claim that the IQ score IPT student higher than the others. Okay, so that's all for exercise 3.2 number 1. Alright, Let's try to solve number 2. In a wood cutting process to produce ruler, so nak buat membaris, the mean of ruler's height is set to be equal 100 cm at all time. Okay, purata ketinggian purata panjang pembaris tu dia set sama dengan 100 cm. So the mu is equals to 100 cm at all time. Okay. If the mean height of ruler is not equals to 100, so kalau mu ni purata dia tak sama dengan 100 cm, the process will stop. Okay. The height for a sample of 10 rulers. So, dia orang ambil sampel 10 rulers and they have this information, they have this data. Based on the sample, can we stop the wood cutting process at alpha 0.01? If we want to stop, mu must be not equals to 100. So we shall test, okay, at alpha 0.01. Okay, what is our step number 1 to test the hypothesis? So where is the hypothesis? This one, we have to test. Is it our mu equals to 100 or our, is it our sample mean equals to 100 or not equals to 100? So step 1, our H null and H1. So the parameter here is mu. Mu is equals to 100, mu is not equals to 100. So equal is always H null. If H null equals, H1 is unequal. So it will stop here. If mu not equals to 100, the process will stop. Okay, step number 2, that will be your test statistic. So which formula you want to use? Z test or T test? Okay, Z test or T test? Do we have the sigma? No, we don't have. Do we have the N? Yes. Do we have the S? Yes, S you can find from this data. Substitute this data into your calculator and come up with the S and the X bar. Okay, so here the X bar is equals to, when you substitute the data into your calculator, you will get the X bar is equals to 100.068 and the S is equals to 0.0811. Okay, I hope by now you know how to substitute the data into your calculator and come up with the mean and the standard deviation. Alright, so now substitute into our formula. So which formula you want to use? Formula number 1, number 2 or number 3? Number 1 cannot because we don't have the sigma. Number 2, Z test. Look at our sample size. Sample size is equals to 10. So you cannot use Z test. So we have to use T test. So T test is equals to X bar minus mu naught over S over square root N. Okay. Substitute into the formula, you will get the T test is equals to 2.6515. Okay, this is your test statistic. Next, step number 3. Okay, and then step 3 is the critical region. So one tail or two tail. So this one is two tail because of the equal sign and unequal sign. So two tail, your alpha need to be divided by 2. So alpha here is 0.01. Alpha is 0.01. So alpha divided by 2, you will get 0.005. Okay, so if you look at our T test, right? So T is alpha over 2 nu. So nu is equals to N minus 1. So N is 10. 10 minus 1 is 9. Right? So now we look at our stat table. T 0.0005. Nu is 9. Okay, look at our stat table. T is 0.005. Nu is 9. Okay, 3.2498. 3.2498. So, two tail. Sorry. Two shaded region. Put negative and positive sign. So, positive 3.2498, negative 3.2498. Okay, and then step 4. Reject or accept H null. Okay, look at our t-test here. 2.6515. Where 2.6515 located at? Is it at the shaded region or unshaded region? Okay, 2.6515 lagi kecil daripada 3.2498 dan lagi besar daripada negatif 3.2498. So, the t-test is here. 2.6515 is here. So, the t-test is located at the unshaded region. Unshaded region is the acceptance region. So, you have to accept H null. So, since negative negative T 0.0059 is equals to negative 3.2498 is less than T test 2.6515 and less than T 0.0059 3.2498, hence accept H null. So, dia berada di tengah-tengah. It is greater than negative 3.498 and is less than positive 3.2498. So, acceptance region, accept H null. Okay, step 5. What will happen if you accept H null? You accept H null here. Okay, so here you accept H null. So, you discard your H1. You accept H null. Right, so now at alpha 0.01, mu is equals to 100. So, if mu is equals to 100, it will not stop the process. Okay, because the process will stop if the mu is not equals to 100. In our case, we accept H null where our H null mu is equals to 100. So, mu is equals to 100, the process will not stop. It will stop if you reject H null and you accept the H1 where the mu is not equals to 100. Okay, continue. Number 3. UMP students said that they have not enough time to sleep. Okay, a sample of 36 students, so n equals to 36, give that the mean of sleep time is x bar is equals to 6 hours and the standard deviation is 0.9 hours. So, this is about the sample because they take sample 36. It is known that the mean sleep time for adult is 6.5 hours. So, it is known that this one is population. Mu is equals to 6.5 hours. Okay, can we reject the hypothesis at 1% significant level? Alpha is 0.01. So, where is the claim? Where is the hypothesis? Here, said that they have not enough time to sleep. So, not enough time to sleep. If enough time to sleep, it will be mu equals to 6.5 or mu is greater than 6.5. Then, you have enough time to sleep. If it is not enough time to sleep, what will happen to the mu? mu less than 6.5. If your mu is less than 6.5, then you don't have enough time to sleep. If your mu is equals to 6.5 or greater than 6.5, you have enough time to sleep. So now you have to test this one. Is it correct? UMP student do not have enough time to sleep. Okay, so step 1, H null, H1. H null, H1, so here is mu. The value of this mu is 6.5. Okay, the symbol less than not enough time, H null or H1. Less than is H1. So claim not enough time to sleep. So if H null, H1 less than, H null greater than and equal. Right. Step number 2, your test statistic. Which formula you want to use? Step number 1, formula number 1, formula number 2, or formula number 3? Formula number 1, do we have any sigma? No, so you cannot use formula number 1. Formula number 2, look at the sample size. Is it greater than 30 or less than 30? 36 is greater than, right? So you can use formula number 2. So the formula number 2 is Z test is equals to X bar minus mu naught over S over square root N. Okay, substitute. X bar is 6 minus mu naught is 6.5 over S. S is 0.9 divided by square root 36. Then you substitute into your calculator. You will get the Z test is equals to negative 3.3333 for decimal places. Okay, continue. Step 3, one tail or two tail? Oh, one tail. Right or left? Left. Because of the less than. So left tail. Left tail. So Z 0.1%, 0.01. So Z 0.01, look at your stat table. It will be 2.3263. So because of it is a left tail, put the negative sign. So when you draw, it will be the left tail shaded region, and put the negative sign, it will be 2.3263. Sorry, here negative 2.3263. Okay, so step 4, accept or reject H null. Accept or reject H null. So look at here, our Z test is negative 3.3333. Negative 3.3333 is less than negative 2.3263. Negative 3.3333 will be located at the rejection region. So you have to reject H null. Since Z test is equals to, so it's not fit here, I will put below. Since Z test equal to negative 3.3333 is less than negative Z 0.01, negative 2.3263, you have to reject H null. Okay, so step 5, what will happen if you reject H null? Look at back our hypothesis. So you reject H null. So you discard this H null. So you accept the claim. So if you accept the claim, means that it is correct that the UMP student do not have enough time to sleep. So we write down here at alpha 0.05. We do not have enough evidence to reject students hypothesis that they have not enough time to sleep. So it is correct that they claim that they did not have enough time to sleep. So MP student, please go get some time to sleep. Okay, exercise number 4. A motorcycle manufacturer introduced a new method of assembling a particular component. The old method had a mean assembly time of 42 minutes. Okay, the manufacturer would like the assembly time to be as short as possible. Thus, he expects the new method to have a smaller mean than the old method of assembly time. So you have here the old mean is equals to 42, and then the new the old method mean. Okay, so the new method mean, okay, he expect to have a smaller mean than the old. Okay, so a random sample of assembly time in minutes taken after the new method had become established was, so the data is for the new method. How many data we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, n is equals to 9. Investigate the manufacturer's expectation at alpha 0.03. So what is the manufacturer's expectation? This one, the new method is smaller than the old method. So how you want to write down the hypothesis? H null, H1. It said that new method smaller, less than. Less than is H null or H1? H1. So mean is mu. So what is the value of this mu? So here the old method is 42. So mu is less than 42. This is the manufacturer's expectation. So if here is less than, H null is greater than and equal. Right? So then step 2. Which formula you want to use? Is there any sigma given? Sigma. No, there's no sigma given. So look at the sample size. N is equals to 9. So you have to use formula number 3. Formula number 3 is T test is equals to x bar minus mu naught over s over square root n. How can we get the x bar? X bar we get from this data. From this data, substitute into your calculator, you will get the x bar. Okay, the x bar here is equals to 36.5556, and the s is equals to 6.6542. So now just substitute into the formula. So x bar is 36.5556 minus mu naught is 42 over s 6.6542 divided by square root 9. Substitute into your calculator correctly, and then you will get the t-test value is negative 2.4546. Okay, done step 2. Go to step number 3. Okay, one tail or two tail? Look at the H1. H1 less than, so it is a left tail. So left tail, alpha naught divided by 2, and it is a negative sign. So T alpha nu. So our nu is n minus 1, so equals to 8. Alpha is 0.03. So T 0.03, nu is 8. Look at your stat table. You will get 2.1982. So put the negative sign because of the left tail. So if you draw the normal distribution, it is a left tail, so shaded region at the left side, put the negative sign, 2.1982. Okay, step number 4. Reject or accept H null. So look at the t-test. T-test is negative 2.4546. So negative 2.4546 is here. Okay, negative 2.4546 because negative 2.4546 is less than negative 2.1982. So it is in shaded region, so it is in rejection region, so you have to reject H null. So since t-test is equals to negative 2.4546 less than negative t 0.038 negative 2.1982, you have to reject H null. Okay, and then step number 5. What will happen if you reject H null? So look at back our hypothesis. We reject H null, so discard our H null. So we accept our claim. So at alpha 0.03, there is enough evidence to support claim that the mean of new method is smaller than the old method. Okay, done.